So now we're looking at quadratic expressions that are actually equations. So yesterday we learned about how, hey, if we have an x squared term, but there's no x term, so just x squared but no x in the middle, we can actually solve this equation like we've solved equations back in this fall. So we can undo subtracting 1. We can undo multiplication with division. Realize I'm really taking the order of operations and undoing them backwards. So undo subtraction and addition first, undo multiplication second. Oh, is that gonna work out to, that's gonna be kind of messy. So we get 46 thirds here. And then we can undo squaring by square rooting. And when we do that, we get a plus or minus. So you'd have some decimal here round to the nearest hundredth. So plus or minus, I don't know what that's going to be, like 3 point something, I believe. All right, so here's what we're doing today. Today, we're going to have equations that are going to have a bx term or a middle term. So if it's factorable, we can use the zero product property. And so here's what the zero product property says. If we have a times b, and we know that that equals 0, then there's a few situations. Then a equals 0, b equals 0, or both equal 0, a and b. So if two numbers multiply to 0, at least one of them's got to be 0. So we can actually use that idea to solve this trinomial right here. Notice how it's set equal to 0. So to do that, we are going to, and by the way, on your notes, I don't have this 4-step process written down. You can definitely squeeze that on the top center of your notes. I made it fit quite easily. You can do it too. So first step, we're going to make sure that this is set equal to 0. If it's not, we'll do that. If there was an 8 over here, I'd subtract 8. If there was a negative 12 over here, I'd add 12 to each side, adding 12 to that constant right there. We'll practice that in a little bit. So this one is set equal to 0. That's cool. I'm going to factor the polynomial, and these will be factorable likely. Not all polynomials are, so there will be other tools that we'll learn about in the future here. So I'm looking for numbers that multiply to 14. Notice this is an easy trinomial or easy diamond problem to do because there's a 1 right there. So numbers that multiply to 14 and add to negative 9. So that's negative 7 and negative 2. So I can now take these answers to my diamond and place them right inside of our factored form. X minus 7 times x minus 2 equals 0. This is equivalent to that. Here we have standard form. Here we have the equivalent of it in factored form. So after we factor, we're going to set each factor part equal to 0. I have 2 factor parts here. This is one of the factors, the x minus 7. And that x is just as important as the numbers. I know when we do these diamonds, we really focus on the numbers, but it's important there's the x with it. And x minus 2 is the other factor. So take one of the factors and set them equal to 0. And take the other factor and set it equal to 0. So x minus 7 equals 0. X minus 0. X minus 2 equals 0. So I've just set each factor part equal to 0. That's the idea that if these two things multiply to 0, to equal 0, then one of them has to be 0. So here's the two things that I'm multiplying together. So now we're not talking numbers, now we're talking expressions. Well, when these two expressions get multiplied together, it equals 0. So either this one equals 0 or this one equals 0. That's why I've set them equal to 0. And now after you set those factor parts equal to 0, just solve your simple equations to figure out the solution. It's that easy. So solve for x. Add 7, add 7. X equals 7. Boom. Undo subtracting 2 by adding 2. X equals 2. Boom. So 7 and 2 are the solutions. if you plugged 7 into this original equation right here in your calculator all at once, make sure you use parentheses around the 7 when you substitute it in, you would get 0. And if you plugged in 2 instead for x, you would, once you did all of this, you would get 0. It is, those are solutions. There's 2 of them. Just like yesterday, we were getting 2 solutions. When the square root of 64 is 8, we get plus or minus 8. Those are 2 solutions. So let's try that again. This is set equal to 0. So now we're gonna look to try to factor it. Numbers that multiply to negative 55 and add to 6. So that is 11 and negative 5. So those go straight into my factored form. Again, realize that that was an easy trinomial to factor, that there's a 1 right there. So I can take my answers to the diamond and put them right in factored form. Now we take this factor part. It is this times that. So I'm going to take this factor and set it equal to 0. So now we undo adding 11 by subtracting 11. 0 minus 11 is negative 11. And over here we get x minus 5. That's the other factor part. We set it equal to 0. So solve for x. Add 5 and add 5 on each side of the equation. We get x equals positive 5. So negative 11 and positive 5 are the solutions. Now realize this is not a coordinate pair. Take a close look there. Those are fancy brackets. Sometimes mathematicians write multiple answers with those fancy brackets. Or you can also say this. They both mean the same thing. But this is quicker to write. So, solve the following quadratic equations by factoring. So we're going to factor. But then we're not done. We have to solve the equation. So it's factored as x plus 1 times x plus 3. But I have to drop down this equals 0. By the way, don't start factoring until it's set equal to 0. That's step number 1. So now take your 2 expressions and set them, or your 2 factors, excuse me. Factor 1, factor 2. Set each of them equal to 0 and solve each of them. And perhaps you can just see, well, if I'm adding 1 to something, this has to be a negative 1. Some of these are pretty simple equations, so you can just kind of do that. Well, negative 3 plus 3 is 0. Yeah, negative 3 is the answer. Or you can undo adding 3. Boom. And away we go. Negative 72. We're trying to add to positive 1, so 9 and negative 8. So we can rewrite this in factored form as x plus 9 times x minus 8 equals 0. So set each factored part equal to 0. Oops, I forgot to set this one equal to 0. Negative 9 makes that become 0. Or solve for x. Cancels. X equals negative 9. Set this one equal to 0. Undo subtracting 8 by adding 8. X equals 8. So we can do this fancy thing if you want to. X equals fancy bracket. Fancy pants. Boom. Either one of these 2 options are cool. It's set equal to 0. Good. This is the easy factoring method. So numbers that multiply to 60 and add to 19. I think that's 15 and 4. It's a messy 5. Let's change that. All right. So x plus 15 times x minus 4. Oops. That's a positive 4. X plus 4 equals 0. So set each factor part equal to 0. Hey, isn't negative 15 going to make this true over here? Yes. Isn't negative 4 going to make this true over here? Yes. Ooh, this one's not set equal to 0. Scary. So we need to subtract 5. If I take 5 away from this, now it does have 0 on the right side of the equal sign. Now it is set equal to 0. Whoa. But subtract 5 from each side. So now we get x squared plus 3x minus 18. So factor 6 and negative 3. So x plus 6, x minus 3 equals 0. So negative 6 is an answer. 3 makes that become 0, that other factor. There's our solutions. Bada bing, bada boom. Let me show you something real quick though. How am I doing for time? Here, these are already factored. So you're skipping to setting the parts equal to 0. X plus 8 equals 0. X minus 6 equals 0. Now, towards the end here, I was showing you how well we can just kind of see what number makes it become 0. Careful here on this one. On number 2, there's my first factor part set equal to 0. Now I'd also have to do this one right here. When there's a coefficient in front of the x, I want you to show your work solving. So we're going to add through, we undo addition and subtraction first, and then we undo multiplication and division. And yeah, you'll end up getting some fractions. So 3/2 is a solution. Whereas over here, if you're cool with just seeing that negative 5 is the solution, or if you want to show your work solving it, you can. Again, if there is an actual number in front of the x, please show your work, such as, oh boy. Let's see if we can find, oh, I thought I factored more of these. Oh, that one probably didn't actually show up on your practice. Like here. I want you to show your work solving for those two factor sets. I know that n equals negative 3 on this first one. I know that x equals positive 4 on this second factor. Show your work here. Good luck. You can always check your answer by plugging it back into the original problem they gave you all at once with a calculator that knows scientific or the order of operations, and then you can make sure it actually equals 0.